Okay. So the question you should have been able to solve yesterday should have been question 2. This question should have been able to should have been able to solve. Calculating the area of the lawn, you need the height of this triangle, and what we did was we separated this. We created a 90-degree triangle using the height length of our triangle that we were given, and we broke it down into this, which allows us to identify that this was the opposite and this was the hypotenuse. In doing so, we would have to use sine to solve this. So sine theta is equal to opposite over hypotenuse. And we plug in our values here. Opposite is h, hypotenuse is 13, and sine 40 is equal to h over 13. Moving the 13 to the other side, we get 13 sine 40 is equal to h. And solving that on our calculator will get you the height. So I'm just solving that out now on my calculator here. So 13 sine 40, and I get 8.4 meters, rounded. If you wrote 8.36 or something, that's fine. I'm just rounding it to the first decimal place here. So once we have the height, we can then plug it into, since we need to find the area of the lawn, we got to plug it into here. So the area is base times height divided by 2. The base of the triangle is 11. The height we just found, which was 8.4, and we divide that by 2. So the area of the lawn that you should have gotten is 46.2 meters square. So therefore, the area of the lawn is 0.2 meters squared. Just like that. So 46.2 meters squared is our area. So identifying that, yes, we know that the triangle is not a right angle triangle. So as a result, we draw a right angle triangle using the height of the triangle, which allows us to solve for the height and then find the area. And then it says, parents want to cover the lawn with sod. How much would it cost to put sod if it costs $13.75 per square meter? So all you had to do here was multiply the two. 46.2 times 13.75, and the cost would be $635.25. Let's write that out better. And so we write the cost to cover the lawn sod is $635.25. So this was question 2. This is what I expected everyone to be at least able to solve, right? Were there any problems or issues with this? Any clarification that you want with question 2? Okay, no questions. So then, example 3. This was a little bit difficult. Oh, I did solve it earlier. Hold on a second. I gotta erase some of this work here. I gotta make sure you guys don't see this just yet. Okay. So, for example 3, this was the difficult question, right? It told you that a communications tower is a distance from a base of a 70-meter high building. And then from the roof of the building, the angle of elevation to the top of the tower is 11.2 degrees. And from the base of the building, yes, 1 second. From the base of the building, the angle of elevation to the top of the tower is 33.4 degrees. Determine the height of the tower and how far it is from the base of the building. Round your answers to the nearest meter. So drawing this diagram, there's a couple things that you'll realize, which is when we look here, right, we're missing a lot of information here. We're missing D, and we're missing height, right? So this is the diagram you should be able to draw. And someone asked me to go back, so we are going to go back just for a little bit here. Okay. So with D and H here, we can then try to figure out, well, what are the triangles we're trying to work with here, right? Well, the main thing we have to realize is that this whole height here, this whole section is H, right? However, this section here, this part here is 70, right? Because it's the same, at least up to the height of the building, it'll be 70 meters, right? So instead, I'll call this top part here from this portion to this portion of the tower. Let's call this X. We don't know what X is, right? So we're trying to fit in some kind of information that we need to figure out, right? So we need to figure out, all right, what is the height? I know that part of it is 70. I don't know the second part. And when we start breaking it down like this, we can see that, oh, okay, so I'm saying that H is X plus 70. Let's keep that in mind, right? The height of the tower is X plus 70. We don't know what X is. We need to figure that out. Once we have that information down, we can then draw our two triangles. The two triangles that you should be able to see are as follows. The first triangle is the triangle that does this, where this is X, this is 11.2 degrees. That's it. That's all the information we know from the first triangle. The second triangle in blue looks a little bit like this, where it's a little bit taller, because it's the whole thing here. Like so. This is 33.4 degrees, and we know that this whole thing here is H. This is pretty much all the information that we know. I'm actually going to change H though, and I'm going to put it as X plus 70. Okay? Let's put in some values that we know. If you want to keep it as H, you can. You just substitute it in later. But this is all the information we have. So a lot of people should have gotten stuck here saying, I have no idea how to do this. We don't have enough information. Like, there's no way to use the 70. Like, what the hell am I supposed to do? It's like, okay. So why don't we do this? We do also realize that, well, the bottom length here of the triangles is going to be the distance, right? That's true. The distance, the gap between the tower for true triangles are going to be exactly the same, right? So what I'm going to do instead is I'm going to relate these two and think, okay, this here is opposite and adjacent. This is adjacent and opposite. And what I'm going to say is for the red one, I'll say tan theta is equal to opposite over adjacent. I'm going to use whatever I have. I'm going to set this up. Whatever I have, I'm going to have to use. Even if it's just variables, I'm going to set it up. So on the left, if we do tan theta is opposite over adjacent, I'm going to get tan 11.2 is equal to X over D. On the right side, tan 33.4 is equal to x plus 70 over d. Okay? So we're just going to do that, just like this. Once we have that down, we think, well, I have two equations and two unknowns. Does anyone know what that means? Two equations, two unknowns. Any ideas what that means? In math, there's this golden rule. If you have two variables that you do not know, you need at least two equations to be able to solve it. And this is true even if you go to like, if you have three unknowns, you need three equations. If you have four unknowns, you need four equations. And the reason for that is because you can keep substituting in until you isolate for one variable. This should seem similar. This is called solving by substitution. You've done this before in grade 10 when you learned linear systems, where you substitute, you isolate for x or y, and you plug it into the other equation and you solve for the other variable. This is the exact same idea here. So what happens here, right? I'm going to say, okay, I'm going to isolate for x. Let's just isolate for x. So what that allows us to do is rewrite this equation as d times tan 11.2 is equal to x. On the right side, if I isolate for x, I'm going to get d tan 33.4. It's equal to x plus 70. I'm going to move the 70 to the left side, and you will end up with d tan 33.4 minus 70 equals x. Can anyone see where I'm going with this? Right? We have these two equations here. Okay? We have made both equations isolated with x, which means these two equations should be equal to each other. So we get d tan 11.2 is equal to d tan 33.4 minus 70, which is just, if I were to write it here, x is equal to x. Can everyone see that? Complicated. If this was a question on test, it would be a thinking problem, 100%. Right? So whoever did this and showed at least some of their work will definitely get their mark towards thinking for their homework check. Right? You don't lose marks for wrong marks here. Wrong answer, sorry. I wanted to see your thinking. I wanted to see how you approach the problem, any ideas that you might have had. And if you solved it, that's great. You will for sure get your marks, right? So this is just showing you here. If you don't have variables, don't panic. Set up whatever equations you have, right? And figure out, can I get enough equations to solve for my variables? And the answer usually is yes. I'm missing x, I'm missing d, or I'm missing h and I'm missing d, for example, right? Then I could say, oh, then I can just solve for, I can solve for one of the variables, I can isolate for it, I can make them equal to each other, figure it out. Now from here, I'm sure some people got stuck and they're like, okay, now what do I do? Tan 11.2, what does that mean? What am I supposed to do with that? It's like, well, tan 11.2 is a number. You can do that on your calculator, right? You just type in tan 11.2. So tan 11.2 is a gigantic decimal, right? And usually we take around 3 decimal places just to be safe for when we do like the actual tan values. So I get 0, whoops, in red, is 0.198D. So the 0.198 is the tan 11.2. I've solved it. And the same thing on the right side, tan 33.4. I get 0.659 d minus 70. Looks like an algebra question now. We can subtract it on the left. And that's going to give us our d value. So 0.198 minus 0.659 gives us negative 0.461 d. I'm running out of space because I wrote gigantically huge. Hold on, let me see if I can reorganize this. Oh no. It's moving the other part that I don't want it to move. Okay, hold on. This is an emergency here. Give me 1 second. I'm going to try to make some extra space for myself. Okay, let's shift that up over here. Shift that up over here. That moves here. That moves here. Fantastic. Lots of extra space. Beautiful. Okay, great. So once we get here, we divide both sides by negative 0.461. And you should get d is equal to negative 70 divided by 0.461, which gives us 151.8 meters. And that's the distance between the two. So that now, with this information, right, this is this part down here. We know that this is 151.8 meters now. That's the gap between the two. So now what? Now what do we do? Well, we need to find the height of the tower. Which triangle would we use, the left or the right, to find the height of the tower? Does it matter? No. But the right one would make more sense because that's the whole tower on the right side. This whole thing is the height, remember? X plus 70 is the height. So we might as well use the right triangle. And so when we actually plug it in here, using this equation, we get to use this again. And we get to plug this into here too. So 10 33.4 is equal to h over d, where 10 33.4 is equal to h over 151.8. And you can now solve for that. We know that we multiply it onto the left, and we plug that into our calculator. So 151.8, 10 33.4 will give us 100. 100.1, sorry, meters. Now I'm going to zoom out just a little bit so you can see our full solution to this problem. Difficult, yes. I'm not saying it's not. Once again, it was a difficult problem, but it is solvable, right? I don't like people saying, oh, this is impossible. I'm like, it's not impossible. You can't assume that every single question is going to be easy peasy, right? You got to think outside the box here and there. And once you figure it out, it feels great. We just want to make sure that everyone is good to go here. Yeah. So now that that is complete, yeah, so the rule that I was talking about was in math, that golden rule is that if you have a number of variables, you should have an equal number of equations to solve for it. So in this case, we had two variables that were missing, x and d, or you can even say h and d, right? Since we're missing two variables, we needed two equations to set up. So even though you don't have the values, I'm going to set up my equations. As long as I get two different equations, you can always solve through substitution every single time. Okay? You can always solve a problem as long as you have an equal number of equations to the equal number of variables. So if I give you a question in university, you start going into questions with three variables, like, oh, what is x, y, and z? And the only way you can solve it is if you had three equations to solve for, right? There's no other way you could solve for it. Okay. So continuing onwards here, will I give you lots of questions like this? No, definitely not. Maybe one, right? But try to resolve this now, knowing how I've kind of written it out for you. Try some of the homework problems, right? Go back to it and see. Are you able to solve these, right? Because a lot of the simple ones with SOHCAHTOA are pretty straightforward, right? It's like, oh, I identify opposite and adjacent. But then we get to these questions where you have to just take one step further, and many people shut down because it's a little more difficult. So we want to get past that hurdle. Okay. So we want to be able to push past that. We want to be able to identify, hey, what's missing? What do I have? Write the equation. Oh, I can isolate, solve. Okay. So that's how you're going to do it here. So, any other questions before we move on from this content from yesterday? Going once. Going twice. Okay. So let's continue onwards here. What you should have, of course, ready is the 5.3 worksheet here, which is applying sine law in acute triangles. So this is the one you should have ready. Once again, if you're late, tell me you're late, or else I'm not going to update the attendance. I don't know who pops in when I'm sharing my screen. So if you came in late, could you type in chat, please, letting me know you came late? Thank you. Yes, or else it would suck if you got marked absent. Right? So make sure you always tell me. Anyone else? Anyone else? I know there's one more person in here that came in late. I know for a fact there's one more person here that came in late. If that person doesn't say anything, I'll mark you absent. Oh, Devon, I got you. You're good. It's actually not you. It's someone else. But thank you. Yeah, Devon, you came in just in time as I was doing attendance, so you're fine. There is still one more person. All right, that person's not saying anything? Cool. Hmm?
I went out a while ago just to change my device.
So I'm going to read out the names that are here. That these are the people that are present. Just to make sure that we're all good to go. Right? Katayun's here, Josu's here, Angela's here, Haley's here, Amir is here, Ashley's here. We have Christian's here, Nayak's here, Fatimata's here, Franz is here, Sydney's here, Kimberly's here, Devon's here, David's here, Wilshire's here, Joy's here, Brooke is here, Sophia's here. Those are the people that I've marked present. If that's not one of your names that are called, Well, that means you're the one that I'm calling out right now, right? Take charge of your learning. Take charge of whether or not you're present or not. Also tells me whether or not you're listening. Okay. Let's continue onwards. 5.3, applying sine law here. So, what's special about grade 11 math is that, well, you've always worked with right angle triangles so far, whether that's in grade 10 with SOHCAHTOA, the first time you're introduced and stuff like that. Like right angle triangles, even with Pythagorean theorem. The restriction was you are only allowed to use Pythagorean theorem or SOHCAHTOA with right angle triangles. So what if it's not a right angle triangle? What the hell do we do then, right? And so now we're going to go over two different ways we can solve for triangles, right? When we have sides and angles, but we just don't have a right angle, right? We just don't have a right angle. Is there really nothing we can do? And the answer is no. The sine law is a special law. It's a special formula. I will give it to you, and it's given in two different ways. The formulas are given here, and I will outline it in red and in blue. It's the same equation. It's essentially three ratios. And the key thing you want to realize is the capital letters, okay? The capital letters indicate angles. The lowercase letters are opposite of their capitals. Do you see this? This is really important when it comes to labeling. Okay? So once again, the capital letters are angles. The lowercase letters are sides opposite to those angles. Okay? Very, very important that you understand the labeling here. Okay? Now, that being said, once we have that down, we get to our two formulas. Why do we have two? Well, that's a good question. For the top one, use it when you are solving for a side, a missing side. Okay? And for the bottom one in blue, whoopsies, that's red. And then in blue here, use it when you are solving for a missing angle. Two distinct uses, and the reason why we do this is because the top it will avoid some weird fraction movement, right? If you use it in their correct way. So in the top one, if you solve for the missing side, it will help you organize your thoughts a little bit faster by just multiplying sine A or sine B to the other side. I'll show you examples of that, right? While for the angle, same idea. We have the angle on top so that we don't have to do some flipping fraction stuff, reciprocal stuff. It just gets a lot of the the annoying fraction stuff out of the way. We don't have to think about it as much, right? So that's the goal here. So when we do sine laws, we want to think opposites, right? So it's called an opposite angle side pair. So A and A are opposite angle side pairs. C and C are opposite angle side pairs. B and B are opposite angle side pairs. So that's really important, right? Understanding what does it mean by opposite angle side pair. So oftentimes I'll ask you, is there an opposite angle side pair? Do you know an opposite angle side pair? If the answer is yes, you can use the sine law. Okay, and I'm going to write that down here. You can use the sine law if you have an opposite angle side pair in your triangle. That's really important. I'm going to bold that and make that bigger. Okay. So this is your one restriction. That's it. Otherwise, you can't use the sine law. The sine law requires to have an opposite angle side pair. So for example here, in example 1, it says determine x to the nearest tenth of a centimeter. Okay, tenth being the first decimal place. The angle is 70, the side is 9.2. Okay, The angle is 70, the side is 9.2. Okay? Notice how these are opposite angle side pairs. If I were to label this, if you like labeling it, feel free to do so. Then this would be small a, small b, small c. We have an opposite angle side pair. We know A and A, right? Done. So that allows us to use sine law. And you'll notice we have angle B, and we can solve for side B, which we have as x. So the way you use the sine law, we are looking for a missing side. So we're going to use the first form of the sine law, and you only need to use two of the fractions. You don't have to use all three, just two. So for us, since we're working with A and B, with how we labeled it, we're just going to be working with A and B. So I'm going to write out A over sine A is equal to B over sine B, just like that. Once we have that written down, we plug in our missing values. 9.2 over sine 70 is equal to x over sine 55. Voila. So we set it up. We have all of our givens, we plug it into our equation, and then we now need to isolate and solve for x. So solving for x, well, we want to get sine 55 to the other side. And since we're multiplying it, it goes on top. And so we're going to get 9.2 sine 55 all divided by sine 70. And that's going to equal x. And notice how because we use the first form, everything is nice and neatly here. Now, everyone should have their calculator out. We're going to solve for x. Make sure you're able to calculate it correctly. The final answer you should get here, you can do this all at once in your calculator, or you can do it part by part. The answer you should get is
Mister,
8.0 centimeters. Yes.
we're looking and solving for a missing side, right?
Yep, right here, this one.
Yeah, so why is the sine 70 and 55? Because that's the angle, right?
Yeah, and that's part of the formula. Sine A and sine B, right? Part of
Okay.
the formula. Capital letters are angles. So you require the angles to solve for your missing side. That is a requirement. Yeah, so it's part of the formula.
Okay.
So once you do the math there, you should be able to get it's technically 8.019, which rounds to the 10th centimeter as 8.0 centimeters. Make sure you're able to get that on your calculator. If you are unable to, let me know. DM me. Because we got to figure this out. Okay? On iPhone calculators, if you're wondering, oh, how do we do this on iPhones all at once? Well, 9.2 times 55 sine is equal to this divided by 70 sine and equals, and we get 8.0. So you can do it all at once on an iPhone calculator too. You just got to be very careful with how you're typing it in.
Mister, can you do it again?
Yeah. So if you're doing it all at once, going from left to right, 9.2 times 55 sine, right? Equals, you have to click equals, and then divided by, which is the division sign, 70 sine equals. All you have to know, if you are not sure now on iPhone calculators, you should be able to realize that when you get to your trig section, like sine 55 or sine 70, you do the number first, then the trig for iPhone calculators. For Android and scientific calculators, you do it exactly as it's written. Nothing different. Okay? So iPhone calculators do the trig in the opposite way, which is number first, then trig. While for Android and scientific calculators, it's the trig, then the number. Okay. Looks like we're all doing it so far, I think. Right? I just want to make sure that we're all good. There seems to be no messages for me here. So we're going to be moving on here. Okay. So here, example 2. Solve all the missing angles and side C. In other words, finish the freaking triangle is the other way to write this question if you're really curious. Finish the triangle. Now, is side C something we can solve for right away? Does anyone know? Can anyone answer that question for me? Is side C something we can solve for right away? Looking at this triangle here, yes or no? Anyone have any idea? We have a yes in the chat. Does everyone else agree with that? Sydney's saying no. That's a very good observation there. Okay. If you want to solve side C, you need angle C. So that's the issue. We don't have angle C, right? So you can't have both things missing in an opposite angle side pair. That is correct. Which means we need to leave C for last. Lowercase c, that needs to be last. Yeah. So that's the identification. So now you're looking at those angle side pairs and thinking, oh, okay, we're plugging it all together. So that's good, right? So the reason why, if I'm not mistaken, Ashley, you were saying because we have an angle side pair, which is true. We do have an angle side pair. That is the first requirement to solving and using sine law, which is absolutely true. So that's the first identification that you want to do. The second thing you want to do is there something else that I know from another angle side pair? And for us, that does exist. It's 16, which means the opposite of that is angle B. So the first one we want to target is angle B because we know its side. So that lets us kind of formulate a plan in how we want to solve this. So then if we solve for angle B, we now have two angles. We can solve for angle C, which allows us to solve for side C, right? So we start to build this plan of attack on how we should be able to figure out these problems. So once again, angle side pair, what really helps a lot is to label the rest of the lowercase letters or capital letters if they are missing. So I'm going to write A and B here, right? Opposite of their angle. And I am solving for a missing angle this time. I am solving for a missing angle. So because I'm solving for a missing angle, I'm going to use the other equation, which is sine A over A is equal to sine B over B. So now we're using this one because we're solving for angle B, right? So when we plug in all the values that we know, we get sine 70 over 23 is equal to sine B over 16. Now, if you don't like having the missing thing on the right, you can just switch their fraction, like you can switch their positions, that's fine. Like you can write sine B over 16 is equal to sine 70 over 23. If you really like having the missing thing on the left, you can do so. That doesn't matter. Which side the fraction is on doesn't matter. Just don't flip it or anything like that. Don't do anything weird with it. So from here, we got to isolate. So we're going to move sine 16 to the left, and we're going to get 16 sine 70 over 23. And that's going to be equal to sine B. Okay? So that's going to be equal to sine B. All right? And then, once you have that down, we need to solve for angle B. So how do we get rid of sine again? And you remember how to get rid of sine? What's the opposite of sine? Sine inverse, thank you. So we're just going to sine inverse this whole fraction. And there's angle B. Would you guys like me to plug in my phone to show you guys how it works on a calculator? To type it on a calculator? I can do that. So I'll try to show it both ways on the screen here. So give me one moment as I plug in my phone in. Wow, why is it so big? What in the world? Okay, fantastic. All right, so on a scientific calculator or an Android calculator here, you type in sine inverse, you get your bracket here, 16. Notice how I'm literally just going to type it exactly as it's written in my calculator. Divided by 23, close bracket. I'm going to leave that on the screen there. I typed it exactly as is, right? 16 times sine 70 divided by 23, and then close bracket equals, and I get 40.8 degrees. And that's B. So I'm bringing that back up on the screen here. For iPhone calculators, gets a little bit more tricky when you start doing this kind of stuff, right? You're going to do the inside of that thing first. So we're doing the 16 sine 70 divided by 23. So we do 16 times 70 sine is equal to that divided by 23 equals, and then sine inverse of that is our answer, 40.8. So I'll say that again. iPhone users, you do what's inside the inverse first. So 16 sine 70 is 16 times 70 sine equals divided by 23 equals, and then sine inverse. You get 40.8. Make sure you get this value now. Make sure you get the practice in typing this value, this into your calculator. And for those of you who have iPhones and don't have scientific calculators, you might right now already be starting to regret not ever getting a scientific calculator, even though your math teacher told you over the last 3 years. I'm looking at some of you. I've taught you for 3 years straight, and still you haven't bought calculators. I shake my head in disappointment. Love, but disappointment. Right? Scientific calculators are useful. Okay. So continuing onwards here. Okay. I'm going to put my calculator over here. Now that we have angle B, we now know that this is now 40.8. Which means we can easily solve for angle C using our triangle rule, right? So C is going to be equal to 180 minus 70 minus 40.8, because 3 angles in a triangle add to 180. So that immediately gives us angle C, which is 69.2 degrees. We can write that into our diagram now, which allows us to now solve for side C. I'm going to give you 5 minutes to do so. Please solve for side C. Okay, please solve for side C. And we will take it up in, not 5 minutes. I'll give you 3 minutes until 2:55. Go. Okay. You should be done or close to finished by now. Setting it up. We're missing C, so I'll do C over sine C is equal to, and I'm just going to use A because those were the starting values that we got. So I'm just going to reduce my error here by using A. If you use B, that's fine. You can use B, right? But try to use the ones that are given to you just to reduce error. But if you use B, you should still get pretty close to the right answer. Usually I give a leniency of a couple of decimal places. So when we plug in our known values here, we get C over sine 69.2 is equal to A, which is 23 over sine 70. Rearranging that, we get C is equal to 23 sine 69.2, all divided by sine 70. And plugging that in on my calculator here. So plugging that in on my calculator here, we got 23 sine 69.2 divided by sine 70. And I get 22.8, which is rounded to 22.9. And that would be your C. Okay. So those would be your answers there for this question. Any questions or clarifications so far with this? If you got 22.8 or 22.9, both are right. It might just be just a slight decimal error. Don't worry, both are correct. Okay. So it is almost 3 o'clock. So what I'm going to leave you here, you do have some homework at the top of your worksheet that's written out. What we're also going to do though here, I'm going to start off drawing this, and then you can solve it for homework as well. So the one thing that I want you to remember, when it says solve the triangle, what this actually means is find all missing sides and angles. All of it. Every single missing side and angle you must solve for. So if we're, working with the triangle, okay, we're working with the triangle here. So let's say we have a triangle like this. You're given, it says it's ABC. Label it however the hell you want. Doesn't matter how you label it. So let's say I do A, B, C like this, right? 28 degrees here. So that means this is 2.4. If I wrote B is here, this is 3.2 here. There's your triangle, right? Doesn't matter what the triangle looks like. You could draw a triangle that looks like this for all I care, right? I don't care what the triangle is. Obviously, this isn't exactly the most correct triangle, right? Or you could draw it like upside down. Like, as long as you're labeling it correctly, I don't have an issue, right? Label your angles. That dictates where the sides go, and you should be able to solve it. So here, before you leave, let's try to target this down. What missing angle or side are we solving for here? Are we solving for side C, or angle B? Which one can we solve for first? I heard it. Angle B is what you're solving for first. Why? We have an angle side pair, which is A, and we have side B, which means we can solve for angle B here, right? We have side B. So look for what you have. That's going to help you target what you want first. Okay? So there's your diagram, there's your guideline, and you can get started on that for your homework for tomorrow. Otherwise, that is it from me
Sir,
today.
I have a
Yes.
question. So does it matter if you solve for angles or sides?
Well, this one you can't solve for angles or sides here. That you can't solve for anything else. So the questions will pretty much narrow it down to what you can solve for,
Okay.
right? Like the only thing you can solve for right now is B.
All right. All right.